Well, it is now 8 o'clock. It's now time for us to start our program. Welcome, everyone, to Virtual Tour of the Universe. My name is Mitch. I will be paying attention to the chat and making sure that all of your questions get, I shouldn't say all, there's a lot of you here. So as I will do my best to make sure people's questions get addressed. Naomi will be our pilot flying us through the universe. And she is an astrophysicist, not to embarrass her, but you are looking at 2007 Young Astronomer of the Year.
Gosh. Welcome back to high school. Yeah.
And Jose will be your host this evening and regale you with all of the weird stories that he knows about things in space.
And I do know a lot of weird stories about things in space. Here in our virtual tour of the universe for adults only, we like to start out the program by showing you some constellations that should be visible in the night sky this evening from the Front Range of Colorado. I know we have a lot of folks tuning in from all over, but eventually you'll be able to see these stars, just maybe not at the specific time we're telling you. And also, we will have some jokes peppered here and there. We'll get a little PG-13. Once we are done with our constellations and constellation stories, we will move on where you can make suggestions in the chat as to what we look at in the universe. You really get to take over the piloting in sort of the second part of the program. And that is really awesome. We'll go to as many locations as we can. We'll answer some questions. We'll throw some more jokes your way. We'll learn lots of cool stuff. Hopefully, there won't be a test. But if you repeat some of these to your friends, they'll think you're smart. So that's a bonus. And
And
at least just get R-rated. Maybe we'll have to see. Listen, we're telling some constellation stories. Those will get pretty close to being R-rated. So right now on your screen, you're seeing a program called Uniview. And actually, this program was developed for planetariums. We're not in a planetarium right now, so everything's going to kind of look a little strange. But this is the night sky is viewed from the Front Range of Colorado. What is it? 10 o'clock tonight?
9 o'clock tonight. And I'm going to interrupt you, Jose, just because we have a brief PSA before we get started.
Oh, yes.
Because, oh, stupid image. Well, okay, we're going to do it without the image because the image just changed on me. Sorry. So we are all excited because our brand new space science exhibit is opening on Friday. Woohoo! Space Odyssey is fully reimagined. It's bigger than ever, and it is so inspired by our community, both our guests, our folks that haven't visited the museum yet, our aerospace partners, our STEM partners, all really informed us on what they wanted from a space science exhibit. And that is what you'll see in the all new Space Odyssey Reimagined. And we are taking your health and safety very, very seriously, following all of the guidelines from the city and county of Denver and state of Colorado, sanitizing the heck out of our interactives so you can have fun, feeling a rocket launch, exploring our all new fantasy spaceship, and more. So we highly recommend you check it out. It opened to members today. It opens to the public Friday. You do need a time ticket because we are capacity limited. And for those of you that aren't comfortable going to the museum yet, that's okay. We've got a virtual tour of the gallery on YouTube right now on our YouTube channel, so you can check it out. But we hope you'll come celebrate with us. I'm like a little kid giddy excited to see this come to life after 4 years of working on it. So we hope you'll be as excited as we are to share it with us.
It's so cool.
My favorite part is the fantasy spaceship. There's a Simon Says game with a disco ball in it and little hidden Easter eggs that do crazy stuff around the spaceship. So definitely check that out. But let's get started with our tour of the universe. Like I said, we're going to start with some constellations that are visible in the night sky this evening. And you can see one pop up right there. We're going to start by telling a story of several constellations that are clustered in the sky close to each other. And this one might be a little familiar because they've made a bunch of bad movies about it. And it is the story of Perseus, Cassiopeia, Andromeda, Cephus, and Cetus. Oh, those fun names to tell. So sort of right there in the middle of the screen that you see, you can see Andromeda. She's the one with chains hanging off of her arms. You can see Perseus. He's carrying Medusa's head there. And you can see Cassiopeia. Of course, without those pretty illustrations, Cassiopeia is just like a zigzaggy line. Definitely looks like a lady in a chair to me, but that's just me, I guess. So we are going to tell the story of these constellations in the sky. If you're familiar with it, well, you just
don't spoil it.
Queen Cassiopeia was the wife of King Cephus and the mother Andromeda. Andromeda was very, very beautiful. Here's our little family-friendly illustrations right there. Queen Cassiopeia boasted that Andromeda was the most beautiful woman in all the world. And as time went by, it was just like worse, constant. All that Queen Cassiopeia would talk about is how beautiful Andromeda was. One day, when she was walking down by the sea, Queen Cassiopeia even said that Andromeda was more beautiful than all of the gods and nymphs in the universe. Well, this was a problem because there were two nymphs hanging out in the water at that time. And when they heard this, they got very mad with Queen Cassiopeia. So they went to Poseidon and were like, hey, Poseidon, this mortal says that her daughter is the most beautiful thing in the universe. What do you think of that? And I'm sure Poseidon was like, I don't really care. But they eventually got Poseidon really worked up about it. You know, this probably kept going back around. And Poseidon was mad. So he went to this giant sea monster, which you can see sort of on the top of your screen right there. And I should say that the top of the screen is south and the bottom of your screen is north when you go out and look for these constellations this evening. So Cephas was going to come and destroy Cassiopeia and King Cetus's home. There he is right there. Very scary sea monster. Terrifying, at least in
I think he looks kind of cute.
When this image was made, he's kind of like a little seal with a little tail there. All right. So Poseidon was really mad, and he told Cassiopeia to take back what she said about Andromeda. Otherwise, Cephas would destroy their kingdom. Cephas, the king, begged Poseidon to let him know what he could do to save his kingdom and his people. And Poseidon was like, well, I guess you could chain your daughter to a rock without any clothes on and let the sea monster eat her. That's in the Hesiod version. Anyway, so, you know, fun thing to do to your own child. And Cephas was like, yeah, no problem. I don't see any problem with that at all. So he chained up Andromeda to the rock, and she had
and
to wait
inspired so many Instagram influencers with that.
Yes. So Andromeda was chained to a rock, you know, and Perseus, having just killed Medusa, was flying on Pegasus nearby, and he looks down and he sees a naked woman chained to a rock, and he sees that she's very beautiful, and he says, oh, I think I'll marry her. Doesn't even know her name, doesn't know anything else about her. Swoops down, but then of course Cephas is there to kill her. What's Perseus gonna do? Be a brave hero and fight the sea monster with his sword and have this big epic battle? No, he just takes Medusa's head out of the bag and shows it to the monster, and it turns to stone, you know. Because why work to be a hero? Yeah, listen, can we also say this about Perseus too? The way he killed Medusa, he was invisible. He could fly. He had a reflective shield, and he came up behind her while she was sleeping and chopped her head off. It's a real hero right there. Anyway, he snatches Andromeda off the rock, and they fly away and get married. And you can see in this painting, like, look at the ink lines on that Nature and Science, Denver Museum of Nature and Science logo. Not a lot of people knew that our logo was found in a lot of these ancient Greek paintings. Anyway, so Andromeda was saved. Cephas was turned to stone, but Poseidon still wanted to punish. Why are there always babies? There's always like little babies. It's a Renaissance thing. So Cephas and Cassiopeia had to be punished, of course, still. And so what they did is they got put into the sky. And Cassiopeia is nailed to a chair, which is that zigzaggy constellation that you can see almost directly over your head when you go out this evening. And her punishment is not only is she nailed to a chair, but because of the change of seasons, these are constellations that you can see almost all year round, pretty much all year round. And so for half of the year, she's upside down. That's more punishment for her. So Cephas's punishment is he has to stay next to her for all time in the sky and listen to her screams because she's nailed to a chair. So fun, wholesome story. All right, we're going to move on. We're going to move on to our next story right here. But before we do, you probably won't be able to see it in the city. That Andromeda constellation, which is once again the lady there with the chains in her arms, there is an object in that constellation that you can see with your own eyes. You don't need a telescope, and it is the most distant object you can see, and that is the Andromeda galaxy, which is our closest galactic neighbor. Now, you can't be near you can't be near city lights or anything else like that. You got to have a really dark sky in order to see it. But it is a really big galaxy. It's larger than the Milky Way. It's about 200,000 light years across, and it's moving toward us. We think in a couple trillion years they might bump into each other. But there's so much empty space in galaxies that no stars will crash into each other or anything like that. It won't look anything at all like a Michael Bay movie. So if you're around, you'll probably be disappointed. We're going to go ahead and pull up Taurus now. And Naomi, if you could not pull up the illustration for a second so we could just see the constellation there. You can see Taurus right now on this image that we're using looks like an upside down, like letter Y, but actually the two prongs there are the bull's horns. Taurus is the bull, one of the 12 constellations. Yeah, right there. It's right near Orion. So if you look out into the east this evening and find Orion, you just look a little off. It's basically holding a shield up in front of Taurus. So that's an easy way to find Taurus if you're having trouble. Yeah, there's Orion right there, hanging out with Taurus in the sky. And so there's a few stories associated with Taurus. Sometimes the stories are like he was the Mynean bull associated, one of the things that was killed by Hercules. But the story that we're going to tell is about when Zeus went and did some of his Zeusy shenanigans. So Zeus was very amorous. There he is right there. He loved to get around. He didn't really care about consent. Some of his stories haven't aged very well. I'll just say that. And one day he was walking, not walking around. He was looking down from Mount Olympus and he saw a beautiful woman named Europa. Europa was a princess and she and her companions were playing in the water on the seashore. Of course, Zeus, he wanted some of that. So he decided that he was going to go down and do what he did best, do his Zeusy thing. But he was worried that if he appeared to her as a god, she would flee from him. So he thought to himself, what shape can I take so that she'll want to spend time around me? So he transformed himself into a great white bull. And listen, I've spent time around bulls. I used to ride horses when I was a kid. You do not want to spend time around those creatures. They are not like cuddly little things you want to curl up with. But that's the form that Zeus decided to take. And he went out in his little bull form and was splashing around in the water, having a good time. And he's like, oh, look at how gentle I am. And of course, Europa and all of the ladies that were with her were amazed at how gentle this bull was. Listen, that's a big deal. Bulls they just want to crush you with their heads if you get close to them. So, they were nervous at first, but then eventually the bull's gentle demeanor, they were putting flowers around its neck and things like that. And
oh, suspense.
Oh my gosh. Dramatic pause, everyone. Big dramatic pause. Can't wait for how he's going to break the tension.
And should we just spoil it? Should I bring up the next image?
You should just bring up the next image.
All right. And eventually, though, this bull convinced Europa to go off with him. If Jose were here, he would point out the big billowing cloth, because there is always a billowing cloth in every image of this Greek and Roman mythology. And because we're keeping it PG-13, we'll let you imagine what happened with all of this. But this is now officially one of Zeus's lovers. And because we like irony in naming things, the 4 largest moons of Jupiter are all named after lovers of Zeus that are not his wife. But Juno, the spacecraft, or AKA Hera, just showed up to bust that party at Jupiter. So
can you bring that image up one more time?
yes, and I apologize for the yellow lines. Sorry, all that's trying to calibrate to a planetarium that we don't have right now. So
can we just
apologies.
appreciate the goofy expression on that bull's face?
Oh, it looks so happy. It's like,
It's
oh,
really great. Okay, sorry. You can make it go away now.
yes. So Taurus is up in the sky. If you take a look, like we said, north is down here. So this is off to our east if you find Orion. And look for that kind of Y shape. And you too can share an inappropriate story of Zeus. Really, when we say this is 21 plus, we say that because Zeus. While we get Jose back, it looks like he may have had some connectivity issues. Our next story coming up is the story of the Pleiades. Do you know this story, Mitch, or do you want me to take this story?
I don't know this story,
All
but
right.
guess.
So
Just
if
bring
we-
up the stars and I'll guess what they are.
All right, so we're going to turn off the image of Taurus, but I'm going to keep it up because it's a nice reference. So the Pleiades are this little star cluster right here. Just this little itty bitty star cluster. If you're looking up at the sky, a lot of people say, hey, is that the Little Dipper? I call it the Little Dipper. If you had a telescope, you could see something more like this. So this is a group of 7 stars and some yellow lines, you know, that are up in our sky. You can see this with your naked eye. It's great with binoculars. And the story of this is of 7 sisters. So these 7 sisters were extraordinarily beautiful, as all people are in Greek and Roman mythology, because why wouldn't they be? We can make them pretty, even if they weren't.
It's the billowing cloth. It really accents our best features.
It is that great wind that always seems to be prevailing in all of these images that just accents their features. And these 7 beautiful women were frolicking upon the earth when the hunter Orion, who we saw just below Taurus, let me turn him on again. No pun intended. And Orion the hunter was well renowned across all the lands for his great accomplishments, from killing fearsome beasts that were plaguing a kingdom, including everything but a scorpion, and thought, these are some of the most beautiful sisters that I have ever seen, and pursued them. Well, in the age of 2020, this wouldn't be cool, but ancient Greek stories, they were pursued so much that Zeus actually took pity on them and turned them into a group of doves so that they could fly away and escape from Orion. And they ended up in the stars grouped together in the group we call the 7 sisters. But if you look at the Pleiades, you can only see 6 stars. And that's because one of the sisters, Merope, who this is seriously the only Creative Commons image of her out there. So thank you, Renaissance art. Stayed behind. And some say it was because she was ashamed that she married a mortal husband here on the earth, and she wanted to stay behind with her husband. And yes, it is the Subaru logo. If you're wondering, so Michael was wondering there. Now, if you've heard this name Merope before, if you're like me, it's not from Greek and Roman mythology. It's actually from Harry Potter, because Tom Riddle's mother was named Merope and actually was ashamed because she married a muggle or a mortal. And so she was left behind by her family as well. So go take a look at the Little Dipper, which we'll zoom back in again so you can get a better view of. But it is a gorgeous cluster of stars. These are not gravitationally bound. They just seem to be associated with each other. And if you have clouds and still want to see it, go check out a Subaru. They're pretty common in Colorado. You'll see that same grouping of stars.
Awesome. Awesome. Well, we have Betelgeuse up.
Yes.
Sorry, not, well, yeah, Orion. Can everyone tell that that collection of stars is an upside down guy holding a sword above his head and a bow? Okay, so the arm that's holding up the sword, that star right in his armpit, that is the star Betelgeuse. And Betelgeuse comes from an Arabic phrase that roughly translates to armpit of the giant. And that armpit star is our best chance to see a supernova in our lifetimes. At some point in the next 1 million years or so, so like really soon, that star is going to explode. And when it does, it'll be bright enough to see during the daytime. And welcome back. Hey!
Yay!
I'm back. Sorry about that.
It was a really dramatic pause, and then we just finished the story. You missed a lot of billowing cloth. I'm sorry.
Yes. Lots
Also, Supernova 2020, I really think this is the best way for the year to go. Unfortunately, some scientists just dashed that hope for us. They did some more accurate measurements because it seemed to be puffing up. Everyone was getting really excited. Maybe we were going to have an explosion. It's not going to affect us. It's fine. It's just pretty. But no, sadly not. It's probably just star spots. So sorry.
Still,
Maybe
sometime.
2021.
It's going to explode sometime.
I think Zeus got mad at the way I was talking about him, so he flipped my computer.
Did you get struck by lightning? Is that what happened? Oh,
did.
jeez.
Now, listen, I can understand why you were confused. I'm a big fan of the dramatic pause, and I normally just milk it for everything that's worth, but it was definitely technical issues. Have we gotten through all of our constellation stories?
We did. We just wrapped up the Pleiades, and we were talking a little bit about Orion and the Harry Potter connection. Also,
Fun.
Orion, Harry Potter connection, one of the Black family members, one of Sirius's family. So just gonna keep wearing that nerd hat and putting it more firmly on tonight. It's good.
The Pleiades, also, if you're from Japan, you call those the Subaru stars, which is why if you drive a Subaru, you got those stars on your car. And lots of people here are from Colorado, so I know a bunch of you drive Subarus.
What does Subaru mean in Japanese?
We're going to, I don't know. I'm not sure what it means.
I thought you were just gonna ignore the question, Jose, and keep going.
Sorry, I was distracted. But yes, so now is the part of the program. We finished talking about constellations that are visible this evening and telling some associated stories. And now is the part of the program where we want to know what you all want to see out there in the universe. So if you have a place you want to see or something you want to explore or learn about, you can pop that into the chat. We'll try to get to as many places as we can. But just to give you a preview of what it's going to be like, we're going to change the screen back to full mode if possible. And we're going to start. There we go. By going to look at something that is also visible in the night sky right now, which is a planet. We're going to go fly off to the planet Jupiter. If you look
Which
down,
we were talking about those moons and that connection to Europa.
Yes, indeed.
And by the way, everyone, Subaru means united. And the stars appear to be united. So.
Ooh, so
Better.
Thank you for using Google, Mitch. I appreciate that.
No, I just thought of it.
So we're getting some really, really great suggestions. Mitch
Yeah.
is going to look at those and kind of go through. If we get lots of repeats, those will probably be the ones that we pick. So while he's going through and sort of taking the temperature of what you folks want to see, we're zooming in here on Jupiter. You can see lots of little lines, and those represent the orbits of Jupiter's moons. Jupiter's sort of like a little miniature solar system. It's got big round moons that orbit on a sort of plane, and then it's got lots of tiny little moons around it as well. If you're wondering what those dots are in the background, that is a representation of the Kuiper belt. So that's just like a byproduct of the program that we're using. But here we've got a really beautiful view of Jupiter. And this is, of course, Jupiter's largest planet in the solar system. That's that Zeus guy. Always got to be the best and the biggest. I didn't mean it. Don't smite my computer again, please. It's covered in storms. That's what those dots are that you see there. And it's a very stormy place. It's a gas giant, so it's made mostly of hydrogen and helium. And you can see these sort of stripes on it, and these are called bands and zones. The darker areas are lower than the higher areas as material moves up and down as the winds blow on Jupiter. And the difference in height is about 30,000-ish feet. So if you were flying over one of the dark areas and in an airplane and you looked out the window, you wouldn't be able to see the tops of the clouds next to you. There's really extreme height differences, altitude changes there in the clouds on Jupiter. The reason it has so many of these stripes is because it spins around really fast. It has the shortest day of any planet in the solar system. It's like a work day, including a commute. It's like 9.5 hours. Like, you know, if you live relatively close to where you work, you know, if you got a long commute, sorry about it. But Jupiter will turn around once from when you leave the house in the morning until you get home in the evening. Well, I guess most of us maybe aren't leaving the house so much anymore, and thank goodness, because we got to stay safe. But you know what I mean.
And
So Jose, we have
I was gonna say this fast rotation though makes Jupiter not perfect, so don't envy Zeus too much. He spins so fast, he's got a little bit of a muffin top bulging out of the middle there. So
Great, bulges out in the
Jose,
middle.
we have a question. How do you know the composition of the planets?
How do we know what the planets are made out of? That's a great question, because it's the same with everything in space, right? I mean, the furthest away from Earth that humans have ever been is the moon. So how do we know what anything beyond that is made out of? And we use the science of rainbows. It's my favorite type of science. This is called spectroscopy. So when you get an element really excited, like, I don't know, you give it free concert tickets or something, like lots of candy or something, and the element gets really excited, it will start to glow. Now, because of the amount of electrons that the element has, it will release photons at specific wavelengths. So when you look at all the colors on the spectrum, it will have spikes in certain colors. And no two elements are the same. These act like fingerprints. And so the science of spectroscopy, when we look at something in space, we don't actually need to go there to figure out what it's made out of. We just need to be able to see the light. And then we can use tools called spectrometers to break down the wavelength and look for those spikes in the light. And then that tells us what the object is made out of. The intensity of those spikes can also tell us how much of that material is in the object. And it can also tell us other things like how much mass the object has and how hot it is. That's one of the main ways we learn about distant stars.
And that is how we know that if you could survive down to the deepest layers of Jupiter's atmosphere, you would smell bitter almonds because of that deadly hydrogen cyanide.
That's right.
Amazing.
Can't figure out what it smells like.
On that note, a lot of people are wondering what's in the middle, Jupiter. Is it chocolate?
So Jupiter is made mostly of hydrogen and helium. And we think, we're still studying Jupiter right now with a spacecraft called the Juno spacecraft, which is named for Jupiter's wife. Also, the 4 biggest moons of Jupiter, Europa, Callisto, Ganymede, and Io, are all people that Jupiter slept with, mostly against their will, including Ganymede, which is the largest, who was a 12-year-old boy. We didn't tell that story. But as Juno is studying Jupiter, we're getting a better idea of what the inside of Jupiter is like. And we think that there is so much pressure inside Jupiter that the hydrogen acts like a metallic hydrogen, and we think that's how it generates its massive magnetic field. We still have a lot of research to do on Jupiter. And the reason we study Jupiter is because we can use Jupiter as a template for the other gas giants. It's the closest one to us. It takes us the least amount of time to get there. It's also the largest. So we can use it sort of like as a baseline for the other gas giants. And yeah, it's really crazy stuff. The atmosphere of Jupiter is about 1,870 miles thick. Considering that the thick part of the Earth's atmosphere is between 5 and 7 miles, that's a really thick atmosphere. And then once you get down to the bottom of the atmosphere, there's so much pressure, about 100,000 times the pressure at sea level. So if you went, you'd be squished. You know, squishy. You'd be squished. Squished.
People are wondering how much bigger would Jupiter have to be for it to be a star?
It would have to be several times more massive. When I say bigger, things in space, big, like in terms of size, isn't as important as how much stuff you're made out of. So like if you multiplied the mass of the Earth like by ×4, it actually wouldn't be that much bigger because it would have more gravity because it has more mass, and so it would get more compressed. So Jupiter would need to be more massive, several times more massive to be a star. And then it would probably be a type of star we call a brown dwarf star, which doesn't shine like our sun. Brown dwarf stars they fuse hydrogen into helium, which is what you need in order to have a star. But like the surface temperature of a brown dwarf star is like 70 degrees Fahrenheit. They don't shine very bright and they don't get very hot. So it wouldn't be really awesome. I loved 2010, A Space Odyssey, the sequel to 2001, and the aliens turned Jupiter into a little star. But that's probably not a thing that can really happen.
It would have been a ultra cool dwarf star. When NASA discovered the TRAPPIST system, which was a cool dwarf star with 7 Earth-sized planets orbiting around it, the press conference was hilarious because they're like, when you have an ultra cool dwarf star, everyone hangs out the planets can be really close to the ultra cool star because it's ultra cool. All right, so people are still confused about the core of Jupiter. Is there a solid core? Can you stand on anything?
No, you can't stand on anything because to stand on things, you need legs. And you know, you at least need to be upright in some form to stand on something or be on something. And the place where Jupiter has something that is standable, that is not just gas, but is standable, has 100,000 times the pressure at sea level. I mean, that's when you're squished. You'd be squished. And listen, humans are made out of mostly incompressible materials. Our stuff can only squish so much, but you'd still be pretty squished. And any robot you sent down there would also be squished. I mean, at 100,000 times pressure sea level, that would squish steel. You'd be squished.
So like Superman could stand on Jupiter about 2,000 kilometers below the surface that we see?
I don't know about Superman. I got to be honest.
Okay, Zeus. What about Zeus?
Well, Zeus, I don't know. The same deal. I mean, he can change form. If he's squished, does he still live? I mean, he could turn into a bowl if he could be squished.
He's magic. Um,
But let's go ahead and move on to another location.
yeah, let's. We got a lot of votes for Saturn's rings and also something explodey. Let's go to Saturn's rings next.
I saw some things in the chat too that were like very specific Hubble images and things like that. And this computer program that we're using, UniView, it's all based on real scientific data. If we have real photos, we use real photos. If we use computer models, it's based on scientific data. But that all has to be programmed into the program. And there is a lot of beautiful stuff in space and not a lot of people who are programming stuff into UniView these days. So we have a limit on some of these things that we can show you. Like we get like pillars of creation and things like that a lot, but we don't really have an image of that in the computer program. So we tend to also pick places that look interesting. And we have some places that are like similar to the pillars of creations and stuff like that.
And
Jupiter, not Jupiter, Saturn, you can see also has a lot of moons like Jupiter. And of course, famous for those beautiful rings. Saturn has several different rings. They're named A through G. There's ring A, B, C, D, E, F, G.
But not that order because, you know, science. We did it in the order they were discovered, not the order from in to out. So have fun with that one, relearning your alphabet.
And when we crashed the Cassini spacecraft into Saturn, it flew between Saturn and the rings, and we found out that hundreds of thousands of tons of material are falling from the rings into Saturn every single day. But since the rings themselves are made up of billions and billions and billions and billions of tons of material, it will take a long, long time for those rings to disappear. Now, the rings are sort of trapped in a tug of war between Saturn's gravity and the gravity of several of Saturn's large moons. It even has moons inside the rings, which are called ring shepherds. And their gravity helps keep the rings in place. There's a lot of debate as to how the rings got there. Some people think that the rings used to be an icy moon that got ripped apart by the gravitational forces of Saturn and its moons. Some people think that the rings were created when icy moons sprayed water into space. Saturn has tides with its moons, just like the Earth and its moon have tides. And these tides stretch and flex its icy moons, which heats them up through friction, and also gives them a really nice massage, you know, so they're always very relaxed, these moons. But that heat might cause liquid water to spray out into space. And this is what the rings would look like if you flew up to them. Billions of little tiny pieces of water ice. There's some dust and other heavier materials in there. And about 0.2% of the rings is actually lost socks from the dryer, in case you ever wondered where those ended up. So I saw a question in the chat just pop up here right here. This is, where did the water come from? Well, you know, it probably formed when in the early days of the solar system. Listen, water is everywhere in space. Space is just lousy with water. I mean, everywhere you look, water, 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 everywhere. And I know that seems different than what we are accustomed to hearing, because on Earth, the water on Earth is special. Well, the only thing that makes the water on Earth special is it's drinkable. Most of the water in the solar system is water vapor, or it is solid water, it is ice. And it is the drinkable kind that we need in order to have life. But yeah, so the solar system is lousy with water. I mean, you cannot turn around and point in a direction without finding water. Which there's a lot of empty space in the solar system, so that's really saying something. Most of these particulates would be smaller than the size of a quarter. I'm getting a message that says my internet connection is unstable. Can everybody hear me?
We can still hear you.
But you're okay.
Okay. So Saturn's rings are really interesting. You know, we're lucky to have such beautiful rings in our solar system. And they were also really confusing to early astronomers, because early astronomers did not think of planets in the same way that you and I do. They didn't think of planets as a place that you might be able to go and visit. And so when they first saw the rings in those early days, back in the 1600s, they were really confused by the rings. They were like, does it have ears? Is there more than one planet out there? Is it a cocktail olive? What is the deal going on with these rings? And the reason they were so confusing is because even though the rings are so wide that you could fit multiple planet Earths from one end to the other. From top to bottom, they're only on average about 50 feet thick. And they're flat, like a little pancake. The reason for that is because of the conservation of angular momentum and the forces that are acting on them. So as they go around Saturn, first of all, in the early days, they probably were much bigger, and then they bumped into each other, and they sort of just kind of settled down. All those collisions either knocked them out or knocked them closer into the middle. Of course, those ones that got knocked out of the rings, or who knows where they're at. And then, of course, as you spin, things flatten out. The momentum that you have is conserved, even as your shape changes. So think about pizza dough. Like if you're tossing pizza dough into the air, which I always do, because I always make pizza from scratch. I'm just kidding. But when you toss pizza dough into the air, as it spins, as you throw it up there and it spins, it flattens out. That is another example of that conservation of angular momentum. Oh, I see a question here says, how do they see the rings in the 1600s? They had telescopes. The first telescope was used by Galileo in 1610. And in the late 1600s, telescopes were all the rage. And listen, making telescopes back in the day was hard work because you had to make your own lenses. And if your lenses were off by just a little bit, then your telescope didn't work. And they would have these like little, they look like little bowls, and they would put sand in there, and they would put a glass ball in there. It would start out as a ball of glass. And then they would just move it around in a circle like this by hand for hours and hours and hours and hours and hours until the sand ground that glass ball down into a lens. And then they would.
I just want to point out that Galileo made the first telescope after he saw one in Denmark and thought it was cool. And so he went and made the first telescope. The difference was that guy in Denmark was only looking at things far away on the Earth, and he never pointed it upwards for some reason.
And I was going
And
to say,
Galileo did make changes. He made it
Yes.
more, he gave it more magnification. He made changes, made it better at seeing things far away. But let's move on to another destination, shall we?
Yeah, let's, Naomi, do you want to fly us to something explodey, and we'll see if Jose can figure out what it is?
Ooh,
oh,
yeah.
I think you'll know what it is, but because it's one of my favorites.
We also got a question, if water is everywhere, why was it such a big deal when they just found a bunch of water on the moon?
Why is it such a big deal that they found a bunch of water on the moon? So water, like most of the things in our solar system, can teach us a lot about what our solar system was like a long time ago. And we think that the situation that formed the moon was a very violent event. We think that a massive planet-sized object in the early solar system slammed into the Earth and may have potentially vaporized the Earth, but that center of mass was still there, so everything started to recoalesce. And then the Earth's moon formed out of that collision. We think this because we expected the rocks on the moon to be like asteroids, which asteroids have been relatively unchanged since the days of the early solar system, but they weren't. They were actually more like the old rocks on Earth. So we had to rethink. When they brought those moon rocks back from Apollo, that was a big surprise because the moon rocks were not the way that they expected. Now, of course, if this big vaporization thing happens, then there's not going to be any water around, right? And so when we find water in the form of ice on the moon, that gives us more data to help us inform our theories, right? It helps us to have a better understanding of how these things might have formed. Okay, so this is an explodey thing. This is a planetary nebula. This is called the Red Rectangle Nebula. This is one of those things that was imaged by things like the Hubble Space Telescope, and somebody from the University of Toledo took the time and effort to program this into this UniView program, which is why we have this really cool 3D model in here. And this is a planetary nebula. So this is sort of this is pretty much what's going to happen to our sun when it starts to die. So stars, like our sun, are a balance between the inward pull of gravity and the outward push of a gigantic continuous thermonuclear explosion. The explosion pushes outwards, gravity pulls in, and you have a nice little shiny star in there. The way this happens is at the core of the star, there's so much gravity and pressure that hydrogen atoms are literally crushed into helium atoms. I'm going to tell you something, and it might make you feel a little sad, but it's like going to a really crowded concert. You know, when you're trying to get to the bar and get that drink, and suddenly a very popular song comes on, and everybody rushes in right where you're walking, right? And you are just squeezed up against each other. That's what's happening to that hydrogen inside the core of that star, but it's being squeezed so hard that it is literally being crushed into helium. It's like if you were at a concert and you and the person next to you fused into a brand new individual. I'm sorry to talk about concerts, but it's like the best analogy I have. I know it's kind of hard here. So as that happens and the star starts to run out of hydrogen, it needs a certain amount of gravity to crush helium, and it crushes helium into something we call the CNO cycle, which is carbon, nitrogen, oxygen. And then after that, it crushes iron. That's only the most massive star. Our star doesn't have enough gravity, and this star didn't have enough gravity to crush their helium into carbon or nitrogen or oxygen. So when they start to run out of hydrogen, gravity starts to win that tug of war. Gravity pulls more material into the core, and the core starts to shrink. As the core shrinks, the core gets hotter. As it gets hotter, it excites parts of the star that get so much energy that they're actually able to escape from the star's gravity. And so the star sort of puffs up and billows out into this gigantic billowy cloud. And that's what we're looking at right here, this planetary nebula right here. This is hot. This is hot. This is hot stuff. It's like 34,000 degrees Fahrenheit, which is one of the ways we can see it because it's hot and it's glowy. Eventually, the particulates in the nebula, the cloud, will spread out and cool down, and we won't be able to see the beautiful nebula anymore. But those elements that are in the cloud, like if this star had planets, and the elements from those planets and moons and things like that, now get spread out into the universe to become more stars and planets and moons. So it's part of that natural life cycle of a star. One of the questions we get a lot are, well, then when does the black hole come along? Well, you need to have massive, massive, massive stars in order to have black holes. Most really large stars, when they die, gravity is so strong that everything gets pulled into the middle, and they have this big, huge explosion called a supernova. And usually the leftover core is called a pulsar or a neutron star. And these are really small, really dense, really massive. They're made out of a lot of stuff, objects. A neutron star, like a teaspoon, would weigh like 300 million tons. And that's because neutrons don't mind being close to each other, like protons and electrons do. But then you need an even more massive star to have a black hole. And very, very, very few stars are massive enough to do that. Now, the wonderful thing about black holes is we can study them with math, and that means we can do the reverse of how big the event horizon, or the part of the black hole you can't escape, would be if things like, say, the Earth, which of course could never become a black hole, it doesn't have nearly enough mass. But if the Earth became a black hole, its event horizon would be less than 1 millimeter across. So when we look at galaxies, the center of galaxies like M87, we see event horizons that are the size of our solar system or larger. And you can just imagine the amount of matter that is in there. Really massive, massive objects. Here's the thing about black holes. They work on the same principles of the universe as everything else. They just, take them into the weird zone, because they're very extreme and very rare. But they work on the same principles of the universe, and gravity's that big one that's super scary. Because in all the movies, they're like, no, Maximilian, we're falling into the black hole. Quick, somebody get Vincent. He's got to bring the spaceship over. If you got that reference, I will be very impressed. And black holes, they're not like gigantic vacuum cleaners. Just like if you got too close to our sun, it would pull you in. But same with a black hole, but they're trillions and trillions of miles away, hundreds of thousands of light years. And so their gravity by the time it gets here does not affect us at all.
So Jose, why is it called an event horizon? And meanwhile,
it's called an event horizon because it's a movie with Sam Neill, and they go to this spaceship that's out by, I think, Uranus, and then they go in, and it turns out, spoiler alert, that the spaceship is evil. That's why. No, I'm just kidding. When you see something in space, and astronomers, anything you see in space is called an event. It's called an event because that makes it sound lofty. So if you see a supernova, that's an event. If you see a collision of two planets, that's an event. If you see an asteroid or comet streaking by, that's an event. We can't see what's going on inside the black hole. We can't see any events. And in old sailor days, you couldn't see beyond the horizon. So that is the event horizon. That is what it is. All right.
It should be called a thing horizon.
Thing horizon.
Yeah, let's head to Pluto. A lot of people want Pluto, and our resident 2007 Young Astronomer of the Year, Naomi, has strong opinions about Pluto.
I do have strong opinions about Pluto because it was what made me cool in high school for like a year. Yeah. Because the jocks wanted to know why Pluto was not a planet. And I was the only one in the school that did. Yay for nerds. So we are going to fly up to
I-
Pluto. We're going to see images here from the New Horizons spacecraft, but I'm going to take a moment, go on a Pluto rant, and then I'll turn it back to Jose.
Okay.
Pluto shouldn't be a planet, but the definition's dumb. So if you look at the definition of a planet, it basically says that an object has to orbit the sun. Cool. We all do that. We got this. But that doesn't count on exoplanets. That's fine. Has to be big enough to be round. Not hard. You have to be about the size of the state of Texas. No big deal. But then the one that gets me is that you have to have cleared your orbit, either meaning if something comes close to you, you need to be able to capture it as a moon or cause it to collide with you. Problem is, Earth hasn't done this. We have tons of near-Earth objects hanging around us. Jupiter's kind of controlled them by making the asteroids in the Trojans and what are the other ones called, Jose? It's the Trojans. There you go. And so it's kind of gravitationally controlled them, but really, if you look at the verbatim wording, we have Mercury and Venus as planets. And that's just not cool. So Pluto got the short end of the stick, but it's still, no pun intended, the coolest place in our solar system.
Can I just say, I've seen some cool stuff in the chat. John says that Neil deGrasse Tyson is their arch nemesis. And I'll say this, I know I'm going to get a lot of blowback from this, but I also am not the biggest fan of Neil deGrasse Tyson. And the main reason isn't because he is an awesome astrophysicist. He is very smart. He is an excellent science communicator. The biggest problem that I have with him is he has a tendency to be very critical of people who are not as scientifically minded as he is. And as a science educator who deals with the public teaching science and stuff like that, that is very damaging sometimes, because if you have somebody who isn't comfortable around science, maybe they didn't really do well in science at school, and they have some maybe not so scientifically accurate ideas about something, and they share that with you, going after them and kind of needling them in a sarcastic way, as he does sometimes, is really just going to make that person not like science. So that's my big criticism. I know I'll get a lot of blowback from that. But I think that, that is a thing that sometimes I think causes more problems than it solves, especially from people who are, let's just say, scientifically skeptical. So Pluto does have a big heart-shaped feature on it. What?
Oh, Jose, you're frozen.
Uh-oh.
He was going to say, oh, wait.
No.
Are you back?
Am I
It
back?
looks like you're back. I think so.
My poor laptop. She's struggling. We've got about 12 minutes left, so we should be able to get through some cool stuff. So Pluto has this feature on it that kind of looks like a heart to us. And it's called Sputnik Planum. It's a huge sort of field of nitrogen ice. Pluto is an icy body. Now, here's the deal. To you, me, and everybody else in the universe, ice is something you put into a glass to make it cold, and it is the stuff that's at the North and South Pole for now, right? At least the next 10 years. But to an astronomer, ice is anything that is a solid once it gets a certain distance away from the sun. So ice to an astronomer is carbon dioxide, oxygen, nitrogen, methane. That is all ice to an astronomer. And so that is what Pluto is made out of. And this big heart-shaped area you see on Pluto is nitrogen ice. It's really cold, about negative 400 degrees below 0 Fahrenheit on Pluto. And you can see these kind of mountains on the edge of that those big nitrogen glaciers right there, which are the Hillary Montes, which are really tall, 1,400-foot mountains on Pluto. And we know a thing or two about 1,400-foot mountains here in Colorado. I saw somebody earlier in the chat say, why isn't Texas round? Because I think, Pluto's just a little bit bigger than Texas. Texas would be round if it was all by itself out there in space. You need to be a certain size in order for your gravity to sort of fold you into a sphere. And I will say this, I saw somebody say this too, just because I saw it pop up in the chat and I wanted to touch on it before we ran out of time. Can you touch space? This is a little mind-boggling right now, but you touch space every time you touch anything because everything is in space. Space is sort of like a dimensional construct between time and ways we can move around, forward, backward, up and down, around and around. So you're even touching space when you're sitting still and time is flowing by. Crazy, mind-boggling stuff. Space, when you touch it.
One quick thing about Pluto and its largest moon, Charon, which you saw going by. There's some really nerdy names that things have been named here. Pluto has a feature named after Cthulhu. It also has a mountain named after Picard, not the starship captain, but it is named after the British scientist who the starship captain is also named after. So it's named after the starship captain. And then
Picard. He is the most British Frenchman in the universe. He and he has a British accent and he's from France.
And then Charon has features named after great explorers like Dorothy Gale, who traveled to Oz, and science fiction authors like Octavia Butler, and others. So very nerdy names. We just have about 10 minutes left, so I think we should go to one more destination. Let's see.
Somebody said, while we're flying, Mitch, do you want to pick a destination for us? Because somebody said, how would I explain the connection between time and space? That's a really hard thing to wrap your mind around. But think about like an XY graph, right? And one line on that graph is time. And the other line on that graph, that XY graph, is space. So that's how you have to think of space-time. That doesn't really help. But if you could, that's two-dimensional, right? That XY graph is two-dimensional. You just got to fold that out till it becomes three-dimensional, which is also why gravity pulls things into a sphere. If the universe was two-dimensional, gravity would pull everything into a plate. But we've got more than two dimensions. So the faster you move through space, the slower you move through time, and vice versa. Weird. We're all little lines on that XY graph.
When most of these planets formed, they were more liquidy. Like when Earth formed, it was a big lava planet, like that one at the end of Star Wars. Can't remember what it's called. So it was much more malleable, and so it was able to be formed into a sphere. Mustafar.
That planet's called Mustafar, and it's a moon. It's not a planet. So...
Sorry. We also heard a request to go to Yavin 4, but I don't think that's in our program.
It's basically Jupiter. I mean, it's a gas giant for sure. Which I'm also amazed that one of the moons of that gas giant has living things on it, because gas giants like Jupiter have really strong magnetic fields. I mean, you can get bombarded with like 2 million rads of radiation there. So you'd be dead. I don't know how they were able to walk around on that moon without getting fried by the radiation. Last location. Where are we flying out to?
It's a guess your location, because Mitch just told me to go somewhere cool, so I did. And we arrived upside down.
Oh yes. We have come to the space car.
Which just arrived approximately around Mars-ish. Not
Yes,
in great shape anymore. Doesn't look this pristine, but you know, it's there.
This is the Tesla space car. This is a Tesla Roadster. Of course, Tesla also runs the SpaceX program, which uses their Falcon rockets, which are the coolest things in the universe because the big boosters take off and then they drop off from the payload and they come back down and land on the launch pad. They were testing something called the Falcon Heavy, which is 3 of these boosters together. 2 would land in separate pads and 1 would land on a barge. And they wanted to have this Falcon Heavy so that they could launch really heavy spacecraft into space. So they needed something really heavy that they could launch out into space. And they didn't have a payload. They didn't have a satellite or anything. So they decided to launch a Tesla car. It has a little mannequin in the front dressed like an astronaut. And after it flew up into space, on the little screen, it said, "Don't panic," like Hitchhiker's Guide to the Galaxy. And it played David Bowie songs as it flew out into space. It was a successful test of the heavy rocket. They wanted to send the car to Mars. They got a little over enthusiastic with the thrust. So the car is actually going to go out past Mars and then loop back around the sun on the other side. So it will cross the orbits of Earth and Mars, go out into the asteroid belt. Probably won't bump into any asteroids. That doesn't really happen in the asteroid belt. The asteroid belt has thousands, millions of asteroids in it, and they're like 2 million miles away from each other. So we don't even worry about bumping into anything in the asteroid belt. So sorry, C3PO. The odds of navigating an asteroid field are actually pretty good. It's pretty easy. And then eventually it might crash back into Mars or Earth, but they don't have any way to steer it. It doesn't have any fuel. So who knows? In maybe in 200 million years, the car will come close enough to Earth that some human or human-like creature can look up and be amazed at our little slice of history. They'll look up and say, wow, an ostentatious electric vehicle spearheaded by a man who runs a company who's really annoying on social media. Man, what a time to be alive. I'm sure that's what those people 200 million years from now will say.
Mostly destroyed by micrometeorites and radiation, but it's fine. It's fine. We just
Yeah, that's true. But
all right. Should we zoom out and do our traditional ending here?
Yes, we have come down to the last 5 minutes of our time together here, and we have a tradition here in our tours of the universe where we like to get a little perspective. And I definitely think with everything that's going on in our world right now, a little perspective is always a good thing. So the first thing we're going to kind of zoom out and look at is our solar system and just talk about, what is in there? What is in our solar system? We've got our sun in the middle, of course. We've got the planets. We've got the moons, the comets, the asteroids, the icy objects in the Kuiper Belt. Our solar system is about 9 trillion miles from one end to the other. That is really big. But if we took all the stuff in the solar system, all the moons, all the planets, everything, 99.8% of all of that stuff would just be the sun. And then we have all these familiar constellations, these pictures we've drawn in the sky over time. They look flat to us, but actually these objects are really far away from each other. The closest star to us is about 4.5 light years away. Light travels about 5.7 trillion miles in 1 year. So just, if you want to know how far away that star is, take 5.7 trillion and multiply it by 4.5. And that, of course, is just a tiny, tiny, tiny bit of the Milky Way galaxy. This computer-generated image is based on real scientific data. We can use basically the same thing that the Doppler radar, the weather person on the news does to map a storm. We can use that exact same technique to map the Milky Way. When things move toward us, they look blue shifted. When things move away from us, they look red shifted. And our galaxy has anywhere from 100 to 300 billion stars in it. We think that almost every star probably has planets or something around it, asteroids or something around it. There's huge swaths. All those dark spots that you see there are actually not where there's nothing. It's where there's so much stuff we can't see through it. Huge, massive clouds, hundreds of light years across. Our Milky Way is 100,000 light years from one end to the other. You can't even think about that. How big is that? Well, if the solar system was the size of your shoe, it's 9 trillion miles, the Milky Way would be larger than the continent of Asia. That is how big it is in scale, if you think about it. And of course, as we're out here looking at the Milky Way, you can see all these other little dots, these little colored dots, and those are other galaxies. If we zoom out, we'll be able to see that they waltz and dance around each other in big clusters, which we call clusters, super clusters. And what you're seeing here is the work of thousands of astronomers who have been looking at telescopes and cataloging this data for their entire lives. I mean, we're looking at generations and generations of work. But really, we've only been able to discover these galaxies for about 100 years. We've had powerful enough telescopes to see them for about 100 years. Before that, we thought that the edge of the universe was the edge of the Milky Way, and it is so much bigger. We zoom out, I mean, it's this veritable field of dots. And when you think about every one of these dots here is another galaxy, and some of them are 4 or 5 times the size of the Milky Way. I mean, we're talking trillions and trillions of stars, quadrillions of planets. The reason you see those gaps there and it looks like a butterfly is because it's really bright in the center of our Milky Way. We can't really see through it. And the reason there's more dots on one side and not the other isn't because there's not as much stuff on the other side. It's because most of our telescopes are in the northern hemisphere of our planets. And then at the very, very back, you can see this swirly color right here. You see some red and some green and some blue. That is the beginning of the universe. Back in the 1930s, people predicted that the universe rapidly expanded because when we look at these distant galaxies, they are moving away from us. They are redshifted. The further away these galaxies are, the more redshifted they are. There's a Belgian priest named Georges Lemaitre who came up with the theory that in the early universe, it rapidly expanded, and that was built upon throughout the 30s and 40s and came up with the Big Bang Theory. Then in the 1960s, there were two astronomers working in New Jersey, and they pointed a very advanced radio telescope for the time at the sky, and they kept hearing this weird buzzing, hissing noise. At first, they thought there was a bunch of pigeon poop in their radio telescope, but that wasn't it. It wasn't local radio stations. No, it was the beginning of the universe. And you can hear this on a radio. You can go into your car, or if anybody still has a radio, you can tune the dial on. Tune between the stations, you'll hear static. And about 3% of that static is the beginning of the universe. And that's going to bring us to the end of our tour of the universe. It was a lot of fun. So sorry about the technical difficulties, but I think we got there in the end. Zeus, I'll make it up to you somehow.
Thank you so much for joining us, everyone. This is so fun. Definitely try to come and check out the new Space Odyssey. If the last one was available for 17 years, so you should have about 17 years to come check it out. So no rush, it'll still be cool if you need to wait until you're comfortable being in a public space. But we do take all the precautions. It's really great.
Yeah.
And it's nice to be in there with less people. But anyway, it's so great. Thank you so much for joining us. I hope you all have a wonderful, and if you go outside right now and look up, you'll see the star field that we started our show with. So you can see if you can spot all those sea monsters and hunters and sisters.
W's and whatnot.
Yeah.
Thank you all so much for joining us. We hope you have a good rest of your evening. Stay safe in this difficult and dangerous time. Stay happy. Keep looking up toward the stars. Bye, everybody.
Thank you all.